Hi guys, so today we're going to be talking about hyperbolas. This is our last conic section that we're going to be learning about. So let's get started with some definitions. Okay. So a hyperbola is the set of all points in your coordinate plane so that the absolute value of the difference of your distances from your foci is constant. Right? So what it means is that any point here on your hyperbola, how far it is from each of your two foci, if you subtract them, it's going to be the same. So whether it's this minus this, or if it's here, this minus this, or this minus this, it's still going to be the same, right? So the difference is ellipse was the sum of the distances were the same. For hyperbola, it's the difference. And we see that also play out in terms of our formula. Okay. So here you can see how they derived the equation for the hyperbola. Okay. But here, this is the parts of our hyperbola. Okay. So like our circle and our ellipse and stuff like that, we also have a center. Okay. Then the distance for A here gives us our vertex. So here's A, so center to one of the vertices of our vertices of our hyperbola. This is A, okay? And then this is C to our focus, guys. And then what's special about our hyperbola is we have asymptotes, and how these asymptotes are derived is that using B, using the distance from A and B, we make a box, and then we go across, and then that makes our asymptotes. Okay. There you go. Okay. Instead of having major axis and minor axis, what we end up having instead is transverse axis is the big one, and conjugate axis is the small one. Okay. So you'll see here transverse axis is 2A, conjugate axis is 2B. And here, to find C for our foci, instead of A squared minus B squared, it's back to our regular Pythagorean theorem almost, which is A squared plus B squared equals C squared. Okay, there we go. Okay. And then here, you can see the equation of our hyperbolas. So whether they are horizontal, opening up like this, or vertical, okay, that depends on which one has A and which one comes first, okay? One thing that's important is that in this case, A does not have to be bigger than B, okay? Instead, it's which one comes first. So this x squared, A squared, if that one's first, then it'll be horizontal. But if it's y squared that comes first and it's being subtracted, then it's vertical, okay? And then you can see if x squared is the one that's first, then it'll affect the foci and the x. If y squared is the one that comes first, then you'll see that it affects your foci in terms of the y. Okay? And then also, likewise, you'll see whether the A affecting the x or the y and giving you the vertex based on where it comes from. Okay? And then here are your equations of your asymptote. Okay? Okay, so let's get started by writing an equation for our hyperbola here. Okay? So here you can see our two vertices. So our center has to be in the middle of that. So between 0, 3 and 0, negative 3 will be 0, 0, which is where our center is at. Okay? So from our center to our vertices, this is A. So this here is A, and so A is a 3 long. Okay. Beep. Okay. Then, since this time we're given our foci, okay, our foci, that is from center to focus, this will give us C. And so here we know that C equals 4. Okay. So to write my equation, I still need B. Okay. So in this case, it's C squared equals A squared plus B squared. So that means 4 squared equals 3 squared plus B squared. 4 squared is 16. 3 squared is 9. Subtract, this will give you 7. So 7 equals B squared which is fine. If I really wanted to know what b is, that would be square root of 7. Okay, but really I can start with just b squared. Okay, we're good? Okay, because it's vertical, that means that y squared is going to be first. Okay, and again, note, right, yeah, okay. Okay, so then, since the center is at 0, 0, there's no y minus 0, x minus 0, so I can leave it as y squared, no minus x squared. Okay. A squared, a is 3, right, based off of this, so a squared would be 9. B is square root of 7, or b squared is 7. So this will be here. Okay. And there you go. There's my equation for my hyperbola. Okay, so why don't you try CYP1 and then come check your answer when you're done. Okay, you should have gotten y squared over 16 minus x squared over 9 equals 1. Okay, if you got that right, you can move on to example 2. If not, here's your explanation. Okay, so here I'm given the vertices, so that will give me A. Okay, and note that for the vertices, it's the y that changed, so I know that y squared is going to come first, and it's going to come with A squared. Okay, so in between 0, 4 and 0, negative 4 is 0, 0, so that's where my center is. And note how it changed from this to this. It was a change of 4, so that's why A equals 4. Okay. And then here's the foci. Foci gives me C, so the change from here to here is a change of 5, so that's why C equals 5. And then using C squared equals A squared plus B squared, C squared, 5 squared is 25, A squared, 4 squared is 16, plus B squared, subtract 16, that gives me 9. 9 equals B squared, B equals 3, not that that matters since I'm not graphing, but now I have B squared to put in here, right? Okay. So again, like I said, since vertices are here with the change of y, that means y squared comes first with A squared, so that's why it's y squared over A is 4, so 4 squared is 16, minus x squared over b squared, and b squared is 9, equals 1. There you go. Okay, now let's talk about the next one, example 2. So the Loran navigational system is based on hyperbolas. 2 stations send out signals at the same time. Okay? A ship notes the difference in the times at which it receives the signal. The ship is on a hyperbola with the stations at the foci. Okay? Suppose a ship determines that the difference of its distance from 2 stations is 50 nautical miles. Okay? Write an equation for a hyperbola on which the ship lies if the stations are at negative 50, 0 and 50, 0. Okay? So this is the foci, right? Okay? And so since this is a change in x, it tells me that it's going to look like this. Okay? And then one of them here is at negative 50, 0, and the other one is at 50, 0. Okay? So this tells me where the center is, because the center will be in the middle of it, right? So the center here, negative 50, 0, 50, 0, the middle of that would be 0, 0. A, I don't know yet. B, I don't know yet. However, it tells me that the stations are here, and it tells me also that the stations are at the foci, so that means C equals 50. Okay? Here, in studying the intercepts, you can see that the difference of the distance from any point on the hyperbola of the station is the same as the length of the transverse axis, or 2a. So what it means is like this point here, this distance here is 2a. And so if it's saying that it's 50 nautical miles apart, that means 2a equals 50, or a equals 25. Okay? So then we can use that to find b, because c squared equals a squared plus b squared. Right? So c squared equals a squared plus b squared. So c squared is 50, so 50 squared equals 25 squared plus b squared. Okay. 50 squared is 2500. 25 squared is 625. And then subtract them. 2500 minus 625 will give me 1875, and that equals b squared. I don't have to find b because in my equation it'll be b squared, not b. Okay, and then again, because the foci are here, right, it changed to x. It tells me that this is a horizontal hyperbola, which means that unlike the other ones we did, it will be x squared first. It will be x squared over a squared minus y squared over b squared equals 1. Okay. So center's at 0, 0, so that's why it's going to stay as x squared and y squared. Okay. A is 25, so a squared 25 squared is 625. B squared is 1875, which we solved for that. And there you go. Right. So what this shows is that a does not have to be bigger than b in the case of a hyperbola. Okay, and so there you go. Okay. So why don't you try this other, they call it additional example 2 in the teacher's textbook, so why don't you try this one, and then once you're done, come check your answer. Okay, you should have gotten x squared over 1225 minus y squared over 3675 equals 1. Okay. If you got that right, you can move on to the last example. If not, here's your explanation. So again, the stations are located at the foci, and since x changes, that tells me it's going to be x squared over a squared minus y squared over b squared. Since these are at the foci, it tells me the middle, which is the center, would be at 0, 0, and that the c value, because it's the foci, will be 70. Okay. Here, the difference of distance is 70 nautical miles, so 2a equals 70, so a equals 35. Using c squared equals a squared plus b squared, 70 squared is 4,900, 35 squared is 1225, subtract it, gives me 3675 equals b squared. I don't have to solve for b because I'm not graphing it, I'm just writing the equation, and I want b squared in my equation anyways. So then it's x squared over a squared, so 35 squared, that gives you this, minus y squared over b squared, which we found here, equals 1. Okay. Okay, so now let's get to graphing. Okay, so here it wants us to find the coordinates of the vertices and foci and the equation of the asymptotes for the hyperbola with equation x squared over 9 minus y squared over 4. Okay, so the fact that x squared is first, it's x squared, and then the minus the y squared, it tells me that it's going to be this way. Okay. I know my center is going to be at 0, 0. This is a squared, and this will be b squared, not because this is bigger, but because this one comes first. Okay, so that would mean a equals 3, and then again, since that's affecting x here, my vertices now are going to change my x. So it will be the x value, my center, plus or minus the a, right? Which in this case would be 3, 0, and negative 3, 0. Okay. B equals 2, right? Which right now isn't that important, but it helps when I'm graphing it. Okay. And then to find c, okay, so c squared equals a squared plus b squared. So c squared equals 3 squared plus 2 squared. 3 squared is 9, 2 squared is 4, so c squared equals, c squared equals 13, so c equals square root of 13. Okay. Foci will be here and here, so affecting the x, so the foci will be adding to the x here. So 0 plus or minus square root of 13, so plus or minus square root of 13, comma 0. And then, so that way we know where to graph it. Square root of 13 is approximately 3.6. So plus or minus 3.6. Okay, so now, and then for the equations of it, because it is, it's going to be horizontal, asymptotes is y equals plus or minus b over a times x. So it'll be y equals plus or minus 3/2 over x. Okay, and you'll see why in a bit. Okay, so let's start by graphing our center, which is at 0, 0. Okay. Then my vertices with A3, I'm going to go right 3, 1, 2, 3, left 3, 1, 2, 3. Okay, so that's my vertices. Okay, and then using that, I'm going to make a line here. So 3. Essentially, I'm making a box. Okay. Then b equals 2. So I'm going to go up 2 from here and down 2 from here. Okay, and this, and that. Okay, and then now I'm going to go from corner to corner and corner to corner to get my asymptotes. Okay, and then you'll see why it becomes that b over a. Okay, so here. This is one. Okay. This is another. Right. And you'll see why, right? Because here, this one is. Oh, sorry, it should be 2/3 because it's b over a. So y equals plus or minus 2/3 x. Right, because you can see for this one, it's up 2, right 3, up 2, right 3, up 2, right 3. That gives this asymptote. And for this asymptote, it's down 2, right 3, down 2, right 3, down 2, right 3, which is that negative 2/3. Okay? And then all I have to do then is, starting with my vertices, go towards the asymptote, but never touch it. And then that's, don't touch it. And that's as good as I need your graph to be. And then graphing my foci at square root of 13 over 0, so 3.6, 1, 2, 3.6 there. That's there. That's my foci. Okay. So why don't you try CYP3 on your own, and then once you're done, come check the answer. Okay, you should have gotten something similar to this. Your center is at 0, 0, and then because x squared comes first, I know that it's going to be horizontal. Okay. So a is 7, so it's going to affect the x value of your center, right? Because center a. So that's why it's 7, 0 and negative 7, 0 for your vertices. B is 5. Okay. And then using a squared plus b squared equals c squared, that gives me a c of square root of 74, which is approximately 8.6. Again, it's horizontal, so it's going to affect x here, so that's why it's 8.6 or negative 8.6, or more exactly, square root of 74. Okay. Then asymptote is y equals plus or minus b over ax, so plus or minus 5 over 7x. Okay. Then graphing, here's my center. A is 7, so here's my vertices, and then this is my beginning of my box to get my asymptote. Right, and then b is 5, so up 5, down 5, so this is to help me find my asymptote. Go across for my box. Okay. So then here the positive 5, 7 is up 5, right 7, up 5, right 7. That's why. This one is down 5, right 7, down 5, right 7. That's this one. Okay. Vertices, connect to my asymptotes, go towards my asymptotes but don't touch it. And then here's my foci. There we go. Okay, so now we're going to move on to our last example here. Okay, where we're going to find the coordinates of the vertices and foci and the equation of the asymptotes for a hyperbola here. Okay, so again, I'm going to start off by grouping my x's and my y's. So 4x squared minus 32x. Right? And then minus 9y squared minus 18y, and then I'm going to move my constant to the other side. Right? Okay, then I'm going to factor out this 4. This will give me x squared minus 8x. And then for the y's, I'm going to factor out a negative 9. This will give me y squared plus 2y, and then equals negative 19. I'm going to complete the square, so b divided by 2, negative 8 divided by 2 is negative 4. Square that is 16. Okay, but when I added 16, remember this is 4x squared minus 32x. Really what I added was a 64. So to balance it on the other side, I have to add a 64. Okay? Then for the y, 2 divided by 2 is 1. 1 squared is 1, so 1 here. But really this is negative 9y squared, negative 18y minus 9. So really I put a minus 9 in. So to balance it out, I need to put a minus 9. Okay. Then I'm going to factor. This becomes x minus 4 squared here. This becomes y plus 1 here, squared. And then negative 19 plus 64 minus 9 gives me 36. Okay? Then again, for our hyperbola equals 1, so to get rid of this 36, I'm going to divide by 36. Okay? 4 over 36 is 1/9, so this will become x minus 4 squared over 9. 9 divided by 36 is 1/4, so here y plus 1 squared over 4, and then 36 over 36 is 1. Okay, so now it's in standard form. Okay? Now I can find my key parts. Okay? So here center is at 4, negative 1. Okay? Since x is first, this is a is under x, so a here, if this is 9, that means a equals 3, and so it's going to affect vertices, right? Since it's under x, it'll change my x, so it'll be plus or minus 3, right? So 4 plus or minus 3 is negative 1, which that will give me 4 plus 3 is 7, so 7 negative 1 and 1 negative 1 on my two vertices. Okay. B, useful later for when I'm doing my asymptotes. So here, continuing, this will be B equals 2. Okay. So then I need to find C from my foci. So C squared equals A squared plus B squared, so 9 plus 4. C squared equals 13, so C equals square root of 13. So from my foci, again, will affect in the same way that my vertices affect. So since it affected x, it will affect x too. So 4 plus or minus square root of 13 over negative 1. Okay, and so then to make it easier to graph, 4 plus square root of 13 will be about 7.6 comma negative 1. And then 4 minus square root of 13, this will be about 0.4 negative 1. Okay. Okay, and then equation of asymptote here. Now that our center is no longer at 0, 0, this is horizontal, so it'll be y minus k equals plus or minus b over a x minus h. So plugging all of that in, my k here is negative 1, so minus negative 1, so y plus 1 equals plus or minus b is 2, a is 3, and then x minus h, x minus 4. That's my equation of my asymptote. Okay, so now let's graph. So starting with my center at 4, negative 1, 1, 2, 3, 4, negative 1. Alright, there you go. Okay, then my vertices is 3 away. Again, it's horizontal because x is first here. So 1, 2, 3 here. 1, 2, 3 here. Okay, I'm going to start by making my lines here. For my asymptote. B is 2, so above my center I'm going to go up 2, 1, 2, my line down 2, make my line, okay, and then I'm going to connect, go across, so here's my asymptote, here's one, here's the other, okay. Then my then I'm going to go out towards it, towards the asymptote, go out towards the asymptote, okay. And then foci is here at 7.6, -1, and the other one is here at 0.4, -1. There you go. Okay, so why don't you try CYP4, and then once you're done, come check your answer. Okay, this is what you should have gotten. Once you completed the square and everything, you should have gotten x minus 2 square over 25 minus y plus 1 square over 9 equals 1. Okay. This is the work for completing the square, so pause it and take a look at that if that's the thing that's messing you up. Okay. So from here then, center is 2, -1, right, because x is with the 2, and then y is with the -1. Okay, and then because x comes first again, it's going to be a horizontal hyperbola. Okay, this is a squared, so a is 5. Okay, and then again underneath the x, so that's why it's affecting the x here. So that's why it's 2 plus or minus 5 -1, which is 7 -1, and -3 -1. Okay, this is b squared, so b is 3. That will help me later with making the asymptotes. Okay. And then with that, I can find C to find the foci. So C squared equals A squared plus B squared. So 25 plus 9 is 34. Square root that. C equals square root of 34. And it will affect the same letter as the vertex, right? So since it changed the x, the foci will also change my x. So 2 plus or minus the square root of 34. 2 coming from the center, right? So then it's approximately these 2 points here, right? Then the asymptote is based off of this equation because it's a horizontal hyperbola. And then after that, I just graph. So starting with my center at 2, -1, okay? So A is 5 away, so 5 away this way, 5 away this way, that's the pink lines here. B is 3, so 3 up, 3 down, that's here, okay? And then my vertices will be here and here. Found earlier. Connect corner to corner to get my asymptotes, and then my hyperbola is going to go towards them, and then here's my foci graphed, pretty close to my vertex in this case. So that's it for today. Have a great rest of the day. Bye guys.